Welcome to the second of a series of videos on the plotting program gnuplot. In the first video, we have seen how to use gnuplot to plot functions or graphs of functions. Today, we are going to talk about how to use gnuplot to plot data which is already there in a file. This data could be something you have got from the internet or some experimental data file that you have created yourself, or something which has come from some source. Now, gnuplot expects the data to be numerical data, numbers and numbers alone, arranged in columns. So, let me show you an example of a data file that I have on my directory. This file is called test.dat and this is what it contains. As you can see, it has 3 columns of numbers and 50 such rows in all, and at the top there is the only non-numerical stuff in this whole file, and these are the headers of the columns. Now, of course, the headers of the columns don't have to be there. You could very well have a file without the headers, but the important thing is the header line, once it's there, has been started with a hash sign. So it is this hash sign which tells gnuplot that this particular line is to be treated as a comment. So gnuplot completely ignores whatever there is on this line. So as far as gnuplot is concerned, this data file has only numbers and nothing else. We will later learn how to handle files which might have other non-numerical characters, but for the time being, let us assume that all our files will be like these, just one or more, typically 2 or more columns of numbers. So now that we have these numbers, I have gnuplot ready and running on another terminal for you. And as you can see, the gnuplot prompt is waiting for us to give a command. And now I want to plot the data which is in test.dat. So to do this, we will use a plot command again. But unlike the case when we are plotting a function, here we have to name the data file. Here the data file is called test.dat and I am typing in its name. Remember, the name has to be within quotes because it's a string, and gnuplot has to be told that this is a constant string that is being given to it. If you say plot test.dat, gnuplot will plot the data in the file. Hold on, which data? After all, the file had 3 different columns. So what exactly is being plotted here? In gnuplot, the default behavior when it's plotting data from a file is that it takes the first column of data, plots that along the x-axis, and plots the second column of data along the y-axis. Right now what you are seeing are a bunch of points whose xy coordinates have been taken from the first and second column of your data file respectively. Of course, the data file plot that we have here does not have axis. As we mentioned the other day, by default gnuplot does not plot axis, but we know how to correct that. So we will issue the command set 0 axis and then of course use replot to plot the data file again, this time with the axis drawn. So here you are. The 2 axes has been drawn. These are the points in the data file. If you remember what we did the last time around, when gnuplot is plotting a function, it evaluates the value of the function at a certain number of points on the x interval used, by default 100 points, and plots actually those xy points and joins them with tiny straight lines. So that with lines is the behavior of gnuplot when it's plotting functions. At least that's the default behavior. When it is plotting data points for a file, gnuplot's default behavior is to plot with points. So each point has been plotted and they have not been joined by straight lines. And of course, actually ask it to join them with the straight lines. So what I will have to do is plot test.dat with lines. And you of course get a rather jagged looking point because all these wiggles that our straightish curve had, presumably because of errors in the data, they are being joined together by gnuplot when it's plotting the curve with lines. You can also see the original points as well as lines when you say with lines points. And there you have it. You can see clearly here that these are the individual points that were there in the data file, and gnuplot has actually drawn tiny lines joining all of them. Thankfully here, at least, the data file was in sequence, that is, as you went down the data file, the points were in order of increasing x. So these lines, when you join them one after the other, they did not go back and forth. If on the other hand, the same data file had been in some random order of data points, drawing the curve with lines would have been pretty distracting, to say the least. By the way, when you are plotting a function, you can also ask it not to use the default with lines option, but plot it with points, for example. So just to show you that, remember we plotted the sin x function last day. If we say plot sin x with points, you can clearly see that the sin x graph that was being plotted actually was really a sequence of points, in this case 100 points. Remember, that's the default when it's plotting a function. Of course, when it's plotting from a data file, the number of points plotted is just the number of points that are there in the data file. You can of course also plot a function with lines points. So now you can see the original purple curve for the sin x graph along with the points that have been marked. Now, going back to the default way of plotting data points, let's get rid of this with lines. So I'm just going to use plot test.dat. So the data is going to be plotted as points. Notice that the points have been marked with tiny plus signs. This again is the default for the first data set to be plotted. In my system, in yours it might differ. It may not be purple pluses, it may be red pluses or red crosses or some other symbol. By the way, how would you know which marker is being used? Or if you wanted to change it, how would you know which marker to want? For that, gnuplot actually allows you a rather nice, simple method. All you have to do is type test at the gnuplot screen and you will see all that your system allows you to have. For the time being, let's just take a look at this. 1 here is a default for the first curve or the first data set plotted. As you can see here, it's a purple line and a purple plus. That's the plus is for the corresponding point. Then you have for the second line, you have a green line and a green cross. The third, you have a cyan line and a cyan asterisk, and so on. So if I wanted to change the default behavior, for example, here I can see that the 7th line is a nice red circle, a filled circle. Suppose I wanted to plot my data file with that. Well, actually I can do that. All I have to do is say point type 7. How did I know that it was 7 that I wanted? Simple, I just ran test and checked which one looks better to me. And now your point type 7 has been invoked. Notice that the color is still the color of the first graph, but the type of the marker used has changed into filled circles because you have stated point type 7. What if you wanted red circles? Well, for that what you have to do is point type 7, line type. This is a bit crazy, but the color is actually associated with the corresponding line, so you have to say line type 7 as well. And now you have both line type 7, which here is just a red color, and point type 7, which is a shape, which is the red thing. Well, if you think that these dots are a bit too big, you can add a point size option. And point size is a numerical factor. It tells you how much bigger the points that will be drawn will be compared to the basic default size. So if you want to make it smaller, let's say by a factor of 0.8, I'll write point size 0.8. And now the points have become slightly smaller. But just to illustrate what happens when you win the other way, if you use point size 2, you get large big circles, which would of course also rather badly overlap in some places. So point type, line type, point size, these are what things you can use to change the appearance of the data points. Now that we have had some experience in how to modify the appearance of the points that are plotted from data files, maybe it's a good time to look back at plotting functions and try to figure out how we could modify the appearance of the curves that were being plotted. So to that end, I've started gnuplot again, and now I will plot two curves. The same familiar two curves from the first video, sin x and cosine x, together on the same graph. And as we can see, the first curve is being plotted in purple. That's the default color for the first line type. And the second curve is being plotted in green. If I want to change the color of the second curve, maybe I want to give it the same color as the first curve, then what I will do is I will plot sin x, comma, cosine x, and after saying cosine x, I will add line type 1. And there you have it, two curves, both with exactly the same color. Notice that sin x, which was the first curve, is being plotted with line type 1, the purple colored curve, by default, whereas cos x, which should have been line type 2 by default, has been explicitly asked to be plotted with line type 1, and that is why both of them have exactly the same color. Also notice that in this case the legend up here is not really very useful. It is telling me that there is a sin x curve and there is a cosine x curve, but given the fact that they have both exactly the same color, there is no way from the legend to tell which is which. So, if you are really plotting two different curves, giving them the same line type may not always be the best idea. So let's try exploring a few more line types. What about line type 3? Line type 3, as you can see, is cyan. This should not come as a surprise if you remember the first video. There we had plotted three curves together and the third curve had been cyan. We can try line type 4, of course. That's a yellow ochreish color. Line type 5 turns out to be yellow. Line type 6, that's greenish blue, closer to turquoise, I guess. Line type 7 is red. and line type 8 is black. Now of course you don't need to mug up any of this stuff, as we have already seen. If you type test at the gnuplot prompt, gnuplot is going to helpfully tell you all that is going on here. It's going to tell you, for example, that the color of line type 1 is purple, line type 2 is green, line type 3 is cyan, and so on. And also notice one more thing. Here we have plenty more line types than 8, but there are actually only 8 colors allowed, and the colors cycle in batches of 8. The later line types differ in the kind of markers that will be used for points, but not in the color of the lines. Now one more important issue is that I might want the curve to have a larger width than what default allows us. So let's say I'm saying plot sin x, which is with line type 1, and cosine x with line type 7 and line width. As you can see here, line width can have different values, and each line width essentially is a multiplying factor. It increases the width of the graph being plotted. So if I say line type 4, what I should get is a sin x curve which is purple as before, and a cosine x curve which is line type 7, so it's red, and 4 times wider than the default value. 4 times wider than, say, the sin x curve. That of course was a mess up. I should have typed line width again, not 2 line types, and this is the correct one. The purple curve is sin x, the red curve, which is thicker because of the line width 4 specification, and red because of line type 7, is the cosine x curve. Of course I can specify line types and line widths for both the curves that I have drawn. So I can say sin x, for example, let's make it line type 8, which remember is black, and line width, say 6. So 6 times wider, and this is what is going to happen. The black curve now, line type 8, is the first graph that is being plotted, namely sin x is also wider than the cosine x graph. If you remember, or you don't have to remember, you can just type test again to see what's going on. You'll see that there are also other things like pattern fill and dash type. I'm not going to talk too much about that, in particular because there are way too many things to talk about, and also because some of these things differ from version to version. In fact, even the color scheme that we are using, purple for the first curve, green for the second, etc., is the default color scheme in gnuplot 5. In gnuplot 4, in contrast, the first curve by default was red. Dash types, on the other hand, was not implemented in gnuplot 4 for many systems. So let me just show you what I can do with that, but I will not talk too much about that because it's very possible that if you are using a different version of gnuplot, it might not very well match. Using dash type 4, the dash dot version, which dash type 4 is showing up. Now I may want to use the same kind of style, that is the same line width, same color, even the same dash type over and over again, and it may be quite a pain to keep on typing everything all the time. To that end, what we can do is define our own line styles. And to define a line style, you will use the set command as always. And what I will do is I will set line style followed by a number which tells gnuplot which line style we are setting. Let's say I want to set line style 9. 9 is an arbitrary number I have chosen. I just don't want to mess up the default line styles which correspond to the smaller numbers, and what I say is line type 7, line width 4, and then if I say plot sin x line style 9, it is going to be plotted with line type 7, that is red, and line width 4. By the way, I should have perhaps already let you on to something. You can actually use abbreviations here. You don't have to type line style, line type, line width, these full words. I could even say set ls, say 10. That's line style number 10 which I'm setting. LT for line type, let's say 8, that's black, remember, and LW6. So once you get used to gnuplot, you may consider using these abbreviations. However, until you get the hang of it, I suggest that you keep on using the full words. They may be a bit of a pain to type, but they actually help you understand what's going on better. And once I have this line style 10 set, what I can do is I can plot, say, sin x with line style 9. Even here, we can use ls instead of line style, and cos x with line style 10. So gnuplot is a bit indulgent. It allows you to use abbreviations. In fact, it even allows you to say P as a plot, because it knows that if it is at the beginning of the command, the only P possible there is a plot. So it will plot. Let me repeat once again. Until you get the hang of all of this, it may be a better idea to stick to the complete words rather than just use this kind of abbreviation. Of course, all that we said right now applies equally well to lines when you are plotting data files with lines. Now let us go back to our data file test.dat. Remember, it had 3 columns of data, and when we plotted the data file using plot test.dat, what it did was to plot the first column of the data file along the x-axis and the second column along the y-axis. As I explained before, this is the default behavior for gnuplot. Notice that here the x is going all the way from -3 to +5, and y is going from somewhere around 0 to +16. These are the ranges of the data which were there in the file itself. Now let us suppose we want to plot, for some reason, the first column along the y-axis and the second column along the x-axis. In order to do that, we need to use an option called using. So it's plot test.dat once again. Then you follow it up with the command using, and then you say which column against which column you want to plot. Of course, the default is 1:2, which means that you are going to plot the first column along the x-axis and the second column along the y-axis. If I use that command, nothing changes in the graph because that was the default behavior anyway. But now, if I instead say using 2:1, I am asking gnuplot to plot the second column of the data file along the x-axis and the first column along the y-axis. And now you see the graph has changed. It's now going from somewhere around 0 to 16 along x and minus 3 to 5 along y, which is just the reverse of what happened before. But that's only understandable. The x and y columns have been interchanged here. Of course, you can also plot, say, the first column along x and the third column along y using the command using 1:3, which gives a nice parabolic curve. You could, of course, use other things like using 2:3 or using 3:2, which will, of course, give the inverse of that previous curve. So whereas the previous curve looked a bit like the square curve, this one looks more like the square root curve. Using is actually much more powerful than just this. It not only allows you to specify the particular column to use along a particular axis, it also allows you to calculate with the data before you plot it. For example, I might want to plot the sum of the first and the second column along the x-axis and the third column along the y-axis. Now this, as it stands, will not work. It is giving you something, but it means something entirely different from what we thought it would mean. And for the time being, let's not worry too much about what this means. We can come back to this later. If you really want to do a calculation, you have to tell gnuplot that you want to do a calculation. And the way to do that is enclose the expression that you are using in a round bracket. Inside the expression, you may use other round brackets, but they will be used primarily for bracketing or function arguments or whatever. But the outer round bracket, when you are using the using command, always tells gnuplot calculate whatever is inside. Now if I try this, I will again land up in trouble. This curve also does not look at all like what we expected. And notice that it is giving me a warning. It says empty x range 3 to 3, adjusting to 2.97 to 3.03. And that's what you can see here. There's only a vertical line here, which means the x value is only one particular value, in this case 3. What has happened? Well, gnuplot has actually calculated, as you asked, the expression inside. We thought that it would calculate the sum of the data in column 1 and the data in column 2. However, it is impossible for gnuplot to know that. Gnuplot thinks that you are asking it to calculate 1 plus 2, which of course is 3. So when you are using calculations to the outer round brackets, what you need to do is explicitly tell gnuplot that you want the data in the first column and not the number 1. For that, you use the dollar sign. $1 means data from column 1, $2 means data from column 2. So if I use this, gnuplot will genuinely calculate the sum of the data in column 1 and column 2, plot that along the x-axis, and the data in column 3 along the y-axis. Notice that since I have not asked to calculate anything on this side, that is, I have not put round brackets around this, 3 means column 3. And now that's exactly what the data looks like. Here the sum of column 1 and column 2 has been plotted along the x-axis, and the data in column 3 has been plotted along the y-axis. You can do even more complicated stuff. For example, you can take the data in column 3, multiply that by 2, subtract from that the square of the data in column 1, and plot that along the y-axis, and in this case, of course, the sum of column 1 and column 2 data along the x-axis. Notice that here in this expression, 2 without the dollar stands for the number 2, so this is 2 times the data in column 3, and this double star 2 again is the number 2. So this just says you are going to raise the data in column 1 to the power 2. And this is what the data file will look like when plotted like this. Now there are many more things that you can do with data files, and we are going to explore these things slowly. One obvious thing is, maybe when you are plotting with some such complicated calculation, the legend here looks pretty awful or awesome, depending on your point of view, and so you may very well want to use a title. As we explained in the last video, title works equally well when you're plotting data files. It's the title of the curve after all. It doesn't matter whether it came from a data file or from a function, and you could use some other data file. So some other legend, whatever you want. And so the legend has changed, in this case, to crazy. We will have many more things to discuss about gnuplot. In fact, in the next video, what we are going to do is we are going to discuss how to define our own functions and how to use our own functions to fit data in a file. So until then, happy gnuplotting.